Hey, conceptual physics students, how about a few hints regarding the textbook assignment on chapter 32? It is on pages 659 to 663, and most of the questions the answers can be found in the textbook similar to the reading packet. So many of them are word questions with a simple check on which section, 32.1 or 32.2, etc. However, a few of them are more mathematical. Let me give you hints about those. So for instance, number 46, and if you look at the number 46, it talks about electrons and coulombs. And remember, a coulomb is a large number of electrons. That's all it is. So what we know and what it tells you is that the charge on one electron, I'm going to call that E minus. E minus is kind of our symbol for a single electron. So the charge on one electron is equal to 1.6 times 10 to the minus 19th coulombs. So that's the charge on one single electron. So one way to write that is 1.6 times 10 to the minus 19th coulomb per electron. Now, it's really nice to have this as a unit. Remember, we can tell how to solve a lot of problems just by looking at the units. So what they're asking is, the question is saying, the question is asking how many electrons are in a coulomb. So that's the question. So really, what we know is the number of coulombs per E minus, per electron. But what we want to know is the number of E minuses, electrons, per coulomb. As you can see, then basically this question is asking the reciprocal. Remember, when you take the reciprocal, you're just turning it over. Top becomes bottom, etc. If we know that there are 1.6 times 10 to the minus 19th coulomb per electron, then all we have to do on our calculator is take the reciprocal. And then we will know the number of electrons per coulomb. That'll give you a hint about number 46. Number 48. Then, as you've read in the book, this symbol, which is Greek letter mu, this symbol indicates 1/1,000,000th. So 1 microcoulomb is the same as 1 times 10 to the minus 6 coulombs. So if I had, for instance, 5 microcoulombs, it would be 5 times 10 to the minus 6 coulombs. So for number 48, as with many of the questions, you will use Coulomb's law. Remember, Coulomb's law is the force that attracts or repels for charged particles is Coulomb's constant K times charge number 1, Q1, times charge number 2, Q2, divided by d squared, d being the distance between the centers. So for this one, you simply apply the force formula. Remember, Coulomb's constant is 9 times 10 to the 9th. Charge number 1 is 1 microcoulomb, 1 times 10 to the minus 6. Charge number 2 is the same, 1 times 10 to the negative 6. The distance between them is 0.30, and then that needs to be squared. This always needs to be in meters. Now notice, this is asking for something on your calculator that we practiced in class. You can do every bit of this in one step, pushing enter at the very end. Don't forget to use second function comma to help you. Number 50 is the same exact formula. F equals K Q1 Q2 over d squared. Well, here in this one, we wonder what the second charge is. They tell us very useful information. They tell us what the force is. We know what K is. They tell us what charge number 1 is, and they tell us what D is, which we can square. So just to look at what you should do first, if I were solving this, I would find the force, multiply it by d squared. So then basically that gets rid of the d squared. So that if you take force times d squared, then the right-hand side is only k q1 times q2. To finish the algebra then, no reason you can't just divide by this and you'd be finished. Number 52. Now with number 52, note the charges are the same. Q1 is the same as Q2. Well, then why not just call them Q so that you could get Q squared? And remember, if you have Q squared and you're solving for it, then you can take the square root. Again, I will use F equals K Q1 Q2 over d squared. This times this will make Q squared. I hope these help.